Well, let's take a look at this graph. Alright, this is the T cell count for people if they have an HIV infection. And here's the average T cell count here per milliliter of blood. And this is time after years, or after infection in years. So you can see when someone's first infected, their average T cell count looks close to 1200, and then it drops, and then it may go back up, it says, and as you have few or no symptoms present. But then as time goes on, your T cell count, you see, goes down. The more years, down, down. Alright, and this is here whenever you have a clinical diagnosis of AIDS. That's usually when things definitely look bad. Now explain why F represents the graph of a function. So if this right here, this line is F, we could do the vertical line test anywhere on this line, and it would touch only once. So what that means is for any X value, you have one Y value. Okay? Now let's use the graph to find F of 8. So F of 8 is like plugging, we don't have a function to plug it into, but we could still use this graph to find F of 8. F of 8 means you plug in X equals 8. So if you go over here to where X equals 8 and you go up to the graph, then you can trace that over to the Y, or to the F of X. And so F of 8 equals 200. Alright, you could also figure out X if you have the answer. So this is like you have the Y. What would the X be? So for 350, 350 looks like, if that's 200 and that's 400, halfway between would be 300. Then halfway between that and 400 would be 450. So if I trace this over, I could figure out what X that corresponds to. And what does it look like? 6. Alright, so X equals 6 would be the value of X that would give me 350. Okay. So there's lots of ways you can use graphs to get information about a function without even having the function. The graph can be used to get information like that. Okay. So let's look at using a graph to help us figure out the domain and range of a function. So domain and range of a function from its graph. So to find domain and range, of course, we have to understand what domain and range mean, right? Domain is the set of all X values, while range is the set of all Y values. And remember, Y is the same thing as F of X. So you could think about it as the set of all F of X values if you wanted to. Alright, so if we have a graph, let's say that we had this graph here. We can figure out the range and the domain of the graph, or of the function, by just looking at the graph. So the domain, remember, is all of the x values. So what you want to do is you want to look at the graph part, and you want to look at what x values could you touch the graph at. So this is the smallest x value that touches the graph, or you could draw a line up and touch the graph at, and that's -2. Okay? Notice there's a shaded circle here. As long as it's not an open circle, that means that we include -2. And -2 is the smallest number in our domain. So the way that we can write that is a bracket with a -2. Then that includes every number to the right of -2, like 1, like 0, like 1, and that's the last one. You see, if I come over here to 2 or anything past 1, I can't trace up and touch the graph. So that means my domain only includes numbers from -2 all the way to 1. And there is a shaded circle at 1. So the way that I can complete this domain, and this is interval notation that I'm using here, is I put 1 because that's the biggest number x can be, and then close bracket. A bracket on each end, or on one end, means that you include the number. And if it's shaded in, or if it's just a solid line, you include it. So you put a bracket. If it's an open circle there, then you put a parentheses. But if it's just a solid line or a shaded line, you put a bracket. Alright, so that's all the x values. That's the domain. Now what about the range? The range is all the y values. So what you want to be able to do for a graph to contain a y value, you have to draw from the, you'd have to be able to touch the graph going left or right. So the first place I could touch the graph going left or right would be at y equals what? 0, right here. That's the first time I could touch the graph. So my range is going to equal, put bracket 0, comma, because 0 is the smallest number. You always put the smallest number first. And then I could draw over and touch the graph, touch the graph, touch the graph, until I get to y equals 3. So 3 is the largest number in my range, and I close that again with a bracket. Alright, so first look for x values, that's the domain. Then look for y values, that's the range. So that tells you the domain and range of that function. Alright, let's do another one of those. Let me find us another graph real quick. Alright, so let's look at this graph. Let's first figure out the domain. Alright, so the domain is going to be x values. So what you want to be able to do to contain a point, or to contain a number or include a number, you want to be able to draw a line from the x-axis up to the graph and touch it. So here's the smallest x value that's in the domain. Notice there's an open circle here on the end. When there's an open circle, we put a parentheses. So parentheses -3. And then we can draw a line up from all of these x values. So it includes all of these, all of these, all of these, until I get to x equals 2. That's the last x value that we have in our domain. And it's a shaded circle. So we put 2 with a bracket. We put a parentheses when it's an open circle. We put a bracket when it's a closed circle or just a solid line. Okay. Now let's do the range. Alright, so we want to figure out which y value could I draw over and touch the graph. You can't touch the graph with any of these y's down here. Even at 0 you can't. But when you get up here to 1, you could draw a line over and touch the graph. So y equals 1 is the first number in, or the smallest number in the range. And look, where you would touch the graph, there's an open circle. So you want to put parentheses, and then that's 1 on the y, comma. Now you can't go up very far until you get to the last place you could touch the graph. And that's at y equals a +2. And it is a shaded circle. So you put 2 with a bracket. So 1 with a parentheses, 2 with a bracket. That means don't include 1, but it's everything between 1 and 2, and you include 2. Alright. Now, not all graphs are just going to have small pieces of the graph. You know, on both of those graphs that we've looked at so far, neither of them kept going on and on forever. Okay, let's look at this graph. You see there's an arrow here at the end of the graph. That means that this graph just keeps going on and on forever and ever and ever in this direction. And it looks like it's going to be going to the left and up forever and ever. Alright? The way that we write forever and ever in numbers is infinity means in the positive direction forever and ever. Negative infinity would mean in the negative direction forever and ever. Okay? And with both of these, you always use parentheses. Because it's just the concept that it goes on forever and ever. There is no biggest number called infinity, or negative, or smallest number called a negative infinity. It's just the concept that numbers keep going on and on forever. Alright, so let's figure out the domain. Now with the domain, remember we want to start at the smallest x first. And so with this graph, I can trace up with the smallest x here, but it has this arrow, meaning it keeps going on and on forever to the left. And this is in the negative direction. So our domain is going to start off with parentheses negative infinity. And then you could trace up to the graph with all of these points here, all of these points here, all of these points here, until you get to x equals 4. Then the graph stops and there's a shaded in circle. So that means 4 with a bracket. Alright, the range, remember, is all the y values. So let's look at the y values on the y-axis. You can't touch the graph, you can't touch any of the graph until you get to y equals what? 0. Y equals 0. And it's a shaded in circle. So I'm going to put bracket 0. Now, from this point on, you can trace over to the graph at all these numbers, and the graph is going to continue to go out and up forever. So this is in the positive direction forever on the y-axis. That's positive infinity. So you put positive infinity with a parentheses. So negative infinity to positive 4 with a bracket is the domain. 0 to positive infinity is the range. Alright. Let me see if I can find one for you to practice on, or maybe even two. Alright, on these two graphs, find the domain and the range. Take a minute to do that. Okay, for this first graph, the domain is equal to, remember it's the x values, so you want to start with the smallest x. That's the smallest x value, and it is a shaded circle. So bracket -2, and that includes all this, all this, all this, until you get to x equals +1, and it's shaded, so bracket again. The range is the y values. So y values, you can't touch the graph or go over to the graph until you get to y equals 0. Alright, and it's shaded, so bracket at 0 all the way until I get to y equals 3. And it's a shaded circle, so comma 3 bracket. Alright. Look at the domain here. The first place that I can touch the graph from the x-axis is at -2, and it's an open circle. So parentheses -2. Then you can touch the graph, touch the graph, touch the graph until you get to x equals +1, and it's a shaded circle. So 1 bracket. The range, that's the y values. So look at all the y values. Alright, and then the smallest y value you can touch the graph is at -1. And it's a closed circle. So bracket -1. And now go up, go up, go up until you get to y equals 2. Y equals 2 is the largest number you can trace over to the graph, and it's an open circle. So 2 parentheses. So that's how you find the domain and range of a function if you only have the graph. And believe me, sometimes it's easiest to tell the domain and range of a function if you have the graph. It's when you just have the equations when it can be a lot more difficult. Alright, now one other thing that you can tell from the graph or from a graph is the x and y intercepts. we call the x and y intercepts, we as in mathematicians, we call it the places where the graph touches the y-axis or the x-axis. A graph could touch the y-axis only. A graph could touch the x-axis only. A graph could even touch neither axis. Okay, so it depends on the function. But if you have the graph, you can tell the intersection points by just looking at the places where it actually touches the graph. For example, this graph here, it touches the y-axis at 3. So the y-intercept is 3. Alright, the way that you can write that as an ordered pair is, how many on the x is this? 0. And then it touches at 3. So this right here, 0, 3, that's the point that is the y-intercept. Okay, so if you're asked to enter in a y-intercept, most of the time it won't just want the number. Having the point is the most correct way to write that. Look at these x-intercepts. This graph touches the x-axis 3 times. So it has 3 x-intercepts. What is y equal to when we have an x-intercept? Every time? 0. Alright, so the way that you would write these 3 x-intercepts, that's going to be -2, 0, 3, 0, and 5, 0. Alright, so that's how we write x-intercepts. So, y-intercepts are places where a graph crosses the y-axis. X-intercepts are places where the graph crosses the x-axis. Okay. That finishes section 2.1. 2.2 is more properties of functions. More on functions and their graphs. Alright, we're going to cover, or first go over when a function is increasing, decreasing, or constant. Let's look at this graph real quick. And let's just try to apply what common sense tells us about increasing, decreasing, and constant to this graph. So usually graphs are read left to right. Alright, so if we started over here on the left side, this graph is going down, 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 and so it's decreasing here, 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 and then I get to some point down here, and then the graph starts increasing, 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 increasing. So we were decreasing here, we were increasing here, and then we get to a point and this graph stays the same. So that's constant. So if a graph is going down from left to right, it's decreasing. Up from left to right, it's increasing. And if it's staying the same, it's constant. Now, when we write the intervals on which a function is increasing, decreasing, or constant, we only use x values. So this is a little different from domain and range. When we describe the intervals on which a function is increasing, decreasing, or constant, we only use x values. Okay? Also, when describing these intervals, we only use parentheses. Okay? So for this graph here, I only use x values. So I start at, on this graph, x equals 0. So parentheses 0, 2, I'm decreasing, decreasing, decreasing until I get to x equals what? 3. So I put 3 parentheses, and out to the side I'm going to say we were decreasing. Now from 3, we start increasing, increasing, increasing until we get to 5. And on that interval, the function is increasing. Alright, and then from here to here, and it doesn't have an arrow, so it looks like we stop at 7. But from 5 to 7, we're constant. Now the reason I write that out to the side, on your test or on your homework, and I know for sure on your homework, the question will ask, on which intervals is the function increasing? So then I have all the information written down, so I come down here and I just write down this interval here. And then the next question may be, on which interval is the function decreasing? Well, so then it's this one right here, so I just come and write that one down. Like on your test, the graph could have all three, decreasing, increasing, and constant, but I might just ask for one of these. So writing them all down is one way that you can make sure that you'll know when is it increasing, when is it decreasing, or when is it constant. Now a graph doesn't have to have all three. A graph could just be increasing, a graph could just be decreasing, or a graph could just be constant. So it really depends on the graph as to which it's doing. So remember, we only use x values when we describe these intervals, and we only use parentheses when we describe these intervals. Okay? So let's look at this graph. All right. So remember, arrows on the end mean that it keeps going in that direction forever. So it looks like this graph is going to keep going up and out forever, and it's also going to be going down and to the right forever. So up and to the left forever, down and to the right forever. So if we want to describe the intervals of this graph, I want to always start on the left side. Since this graph is going up and out forever, I want to open my first interval with negative infinity. So parentheses, negative infinity. And then what am I doing from left to right. I'm decreasing, 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 decreasing until I get to x equals 0. So from negative infinity to 0, this function is decreasing. And then from x equals 0 to until I get to x equals 2, I'm increasing. And then from x equals 2, I'll start going down, 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 down forever in the positive direction. So that's 2 to infinity. I'm decreasing again. So that's another reason why it's important that you write this down if you can, if you have the time, because what if my question would have been on which intervals is the function decreasing? Well, I would need to know both of those. So either you have to come over here and just figure out those, or you write them all down and then you just look and see which ones were decreasing and you got your answers. So you'd have 2 answers on this one. All right. Okay. I want you to figure out the intervals for this graph. Take a minute or two and write the intervals on which this function is increasing, decreasing, or constant. Alright, so starting on the far left, I'll start negative infinity. Alright, and so I'm going up, up, up. So I'm increasing until I get to x equals -1. Right here is where I stop increasing. So I'll put -1. Then I'll remind myself, so I write over here to the side, I was increasing on that interval. Then the next interval starts with that same number that I ended with, from -1 until I get to +1. Right here, I'm decreasing. And then from +1, see my graph, I'm going up, 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 and it's going to go up and out to the right forever. So the way we write that, to the right forever, that's positive infinity. So that's from +1 to infinity, going to be increasing. Okay, so left to right, always use x values. If you have an arrow on each end, that means that you will always start with negative infinity and end with positive infinity. Alright. I may not test you on this, but just real quick, if you ever hear the word maximum or minimum used with a graph, it's just like it sounds. And your book uses relative maximum and relative minimum. There's actually several sections in calculus that's just devoted to this, relative minimum and relative maximum. And what a relative minimum is it is a high point of the graph. I'm sorry, a relative minimum is a low point of the graph. A relative maximum is a high point of the graph. So just like you would think maximum means biggest, a relative maximum is a high point. Minimum means smallest. A relative minimum is a low point. Okay? So, just in case you ever see that, you kind of understand what's being talked about, but I'm not going to work out any problems with that. I usually do not test on that. But even if I did, it's not a hard concept. You know, high point, maximum, low point, minimum. All right. Now let's talk about symmetry. We can call a function even or odd if one of the following conditions is met. Okay? A function is even if whenever you plug in negative x for every x and work it out, you get the same function that you started with. So if you find f of negative x, that means plug in a negative x in parentheses for every x in the problem, and you get the same thing that you started with. It doesn't change anything once you simplify. Then we say a function is even. So for example, if f of x equals x squared and I find f of negative x, then what does that mean? That means if I plug a negative x in right there in parentheses and I work that out, negative x times negative x is positive x squared. So you see I get the same thing here and here. I get what I started with. That means that f of x equals x squared is an even function. Alright. A function is said to be odd if whenever I plug in a negative x, I get exactly the opposite of what I started with. So every term is opposite, meaning if a term was positive in the original function, it's negative in the function that I just came up with. So every term would be the opposite. For example, let's say that I had f of x equals x cubed minus x. So to tell if that function is even or odd, then I would find f of negative x. So plug a negative x in parentheses for every x. That would give me negative x cubed means negative x times negative x times negative x. Negative times the negative is a positive, times a negative is a negative, x cubed. And then minus negative x is plus x. Now let's compare each term of my function that I just got out with what I started with. So negative x cubed, positive x cubed. Positive x, negative x. Every term is exactly the opposite, has the opposite sign. So that means that f of x equals x cubed minus x is an odd function. Now, every function doesn't have to be even or odd. It could be neither. It's just we don't call it even, we don't call it odd. It's just neither. That would happen if a combination of these two things happen. Some of the terms are the same, some of the terms are different. So, for example, let's say that I had f of x equals x squared minus x. So to tell if this is even, odd, or neither, I need to find f of negative x. So that means plug in a negative x for every x. Alright, so negative x squared is negative x times negative x. That's x squared. And then I have minus negative x. That's going to be what? Plus x. Now compare what we got with what we started with. Positive x squared, positive x squared. They're the same. Positive x, negative x. They're different. So I had a combination of the two. Some of the terms were the same, some of them were the opposite. So we can say that this function is neither even nor odd. It's just neither even nor odd. Alright, I want you to do the same thing with these three functions. Tell me, is the function even, is the function odd, or is it neither? Alright, so for this first problem here, for A, if I find f of negative x, it's going to be negative x squared plus 6, or x squared plus 6. So compare what we got with what we started with. It's the same. So that means this is an even function. Okay. Part B, find f of negative x. This is 7 times negative x cubed minus negative x. So that's going to be negative 7x cubed plus x. Let's compare what we got with what we started with. Each term is opposite. That means that this is an odd function. Alright, and the last one here, I know that that was a G and I used a F, but it means the same thing. That's because this last one is an H. So H of negative x, that would be negative x to the 5th plus 1. It's negative x to the 5th plus 1. Okay, so compare this to what we started with. The first term is the opposite. The second term is the same. It's a mixture of the two. So this is neither. It's neither even nor odd.